Hello, today we're going to look at modelling current and voltage in a circuit. Nobody's seen an electron or an atom, so it's very difficult to get your head around some of these terms. What we're going to do today is we're going to make a model that represents what happens in an electrical circuit. I hope this helps you. This is the circuit that we're going to be modelling, but any circuit that you could build in the class could be used for this model. So we have 2 cells, 3 lamps and a switch. I've also set that up using the FET model here. There's my switch, 2 cells, 3 lamps. When I close the switch, the electrons will flow around the circuit. So what I'm going to do is I'm going to model what's happening here. So if you can write this into your jotters and fill it in as you go along, and it'd be great if you can do your own diagram of your model. On this side of the table, we're going to have what my model represents. And on this side, it's what's the electrical equivalent. So we're going to start with our first model. So very simple. All we've got here is a road and a bridge. The road, I'm hoping you'll realise, represents the wires of your circuit. And the bridge up here represents the switch. And there's water under the bridge. Normally I put mostly harmless under there. So the road is the wires and the bridge is the switch. Now, there'd be no reason to have any vehicles on the road if you just had a bridge and a circuit like this. This is a town called Circuit. So what we're going to do is we're going to put something very special in this town, because this town has a Mars bar factory. Mars bar is very important because Mars bars give you energy. So here we've got a factory producing energy in the form of Mars bars. What do you think the Mars bars would represent? Mars bars represent energy. The Mars bar factory represents the power supply. It's the reason for vehicles to be on the road. I don't get my Mars bars from the factory. I get my Mars bars from shops. So what delivers the Mars bars from the Mars bar factory to the shops? Well, it's lorries. So we're going to have some lorries. We're going to have some shops. But there's something special about our road here as well, in that our roads around a town called Circuit only allow vehicles in one direction. The vehicles on the road can only travel around the roads in Circuit around this way. So we're going to put some stores in our model. And remember, our circuit at the beginning had 3 lamps. And to represent the lamps, I'm going to use 3 shops that sell Mars bars. I'm going to pick 3 local stores, and we've got Mostly Harmless now coming under the bridge. So our model's building up nicely. We've got the bridge that represents the switch. We've got the 3 lamps represented by the shops. We've got the Mars bar factory representing the power supplies, and the roads only allow the vehicles in one way. So if we go and fill in our table, what we haven't looked at yet, and it's here I've marked it, is what is it that carries the Mars bars to the shops? I'm sure you all know that that's lorries. And here I've got my lorries. And my lorries here represent the electrons. So these electrons will move around the circuit. They'll make a delivery to Aldi. They'll make a delivery to Tesco. They'll go over the bridge. They'll take a delivery to Sandu stores. They'll go back to the factory, get filled up with more Mars bars, and away they'll go again. Now there's lorries all the way around the circuit. They don't all start from the Mars bar factory, but they all head towards the Mars bar factory to get filled up with energy. If we go back to our simulation, here we've got electrons moving around the circuit. Here's one shop, here's another shop, here's the bridge, and here's Sandu stores. So we've got the idea of what's happening in an electrical circuit, but I want to think about some of the measurements we've made. We've used meters to measure the current and the voltage and the resistance. We are going to model measuring current and measuring voltage. And we're going to use the counters at the side of the road. When I was at school, we had to do a survey. We all stood at the road at one time and we had to count how many cars went past us. So here, these represent my counters. They could be you, or people standing at the side of the road, taking measurements of how many lorries go past them in the whole period that they're standing there. And that would be like measuring our current or measuring using an ammeter. So my question to you is, which counter is going to count the most lorries that go past them in a certain time? Another thing to notice is that I've changed the name of my town, because when it got built up like this and we built the factory and the 3 stores, we called it a series circuit. Why did we call it a town called Series Circuit? Because if you look, there is only one path. If I click on this lorry, there is only one route for these lorries to take. The lorries cannot have a choice about the route that they take. They have to go one path. One path is a series circuit. And what I'm going to do is I'm going to draw around this. Each time I draw a pencil line, that's representing one lorry moving around the circuit, or one electron, or one group of electrons. In reality, there are millions and millions of these electrons moving around a circuit. So we're going to call this counter 1, counter 2, counter 3, counter 4, counter 5. I want you to think about which counter is going to count the most electrons. And away we go. Okay, so just count the lines that go past. Ooh, whoops, sorry, I'm not very good with the pen. Oops, over the bridge this time, whoops. Oh dear, these lorry drivers, I think they need to come to our road safety talks. I've lost count. Okay, we'll stop there. So what we need to do is at this point, we need to count how many lines there are, because each line represented a lorry. So let's have a look. 1, 2, 3, 4, 5. Let's check. 1, 2, 3, 4, 5. So this counter, this ammeter, measured 5. 1, 2, 3, 4, 5. Definitely went off the track there. They got 5. Here, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So what you found is in a series circuit, the current, which represents a group of lorries in a certain time, is all the same anywhere in the circuit. And we can show that. This is our circuit again. We've seen that when you close the switch, then the electrons move around the circuit, lighting the bulbs. If we go to our model, we've got the lorries moving around the circuit, delivering Mars bars, which give you energy, to the shops, which you can sell to change your energy. And then those lorries deliver to each of the shops. Some people would say, well, doesn't the first lorry deliver to the first shop and the second lorry deliver? No, every lorry delivers to every shop, because if you were owner of Sandu stores and you saw a lorry driving past with the Mars bars on and you were a bit annoyed because he went right past your front door, so you'd expect a delivery, even if it's a smaller delivery. And we've measured that and set that up. If we look at this, here I've set 5 ammeters around a circuit, and we're going to see what the current would be. And remember that you'll get no current when the switch is open. And from our model, you should know that when I close the switch, the current should, let's have a look. Well, each ammeter has a current of 0.60 amps. And that's exactly what we found in our model. So it looks like it's a pretty good model and explained it clearly. So just to show you that our model does work, this is me. I've added meters. You can't see this one very clearly, and you can see that the current is the same. See, current is all exactly the same, 0.100. Notice the light bulbs aren't all the same brightness, and that doesn't matter. I said I'd come back to the reason why we represented the bridge as a switch with water underneath it. And there's a real problem with our circuit. Let's have a look at this video, and you might find out why. Whoops. Bridge is going to have to be looked at by the health and safety to make sure the bridge is safe. If we went back to our model and we had a look and the water level rose and either flooded the bridge or somebody in a canal boat came and crashed into the bridge, then our circuit is not going to be operational because there's no route for the current, the lorries, the electrons to take. Let's have a look. So here we go again. There's a canal boat that's rammed into the bridge. So if this bridge is taken out, can any of the lorries get past? Well, they can get as far as here. They could get over here, but they can't go round. Now, all these lorries will have sat-nav on them. And they will know that the bridge is out. That's the route stopped for the lorries. So that's not the best circuit.